Hi
Okay,
everyone,
cool.
welcome to the last session of ZK month. Today we'll be culminating with our final session of a month-long series of talks and sessions about all things ZK. And today we have with us our amazing speakers from the Mina Protocol. We have Regina with us, we have Jack, and we have Samuel. I'd like to hand it over to you, Regina, and go over a bit of introductions and we can get started.
Okay, let me see. I think someone's mic is on. Let me see if I can.
Let me check. Folks, if
Okay.
you're asking a question, it would be great if you can be on mute so as to ensure a good session. Yeah, thank you.
Oh, cool. Awesome. Let me share my screen, and I'm also not sure. Yeah, feel free to interrupt if there's a question or anything comes along. Because I notice I'm not able to see. Oh, hey, Jack. Yay. Okay, cool.
Hey, sorry, I was just figuring out my camera. Zoom is weird after the OS X update. But anyways, sorry, go on.
Okay, great. No, this is awesome. Yeah, this is Jack. Can everyone see my screen or
Yes,
only the screen with the slideshow that says build your own ZK app?
yes, we can.
Okay, cool. Then let's get started. Hi, everyone. My name is Regina. I'll introduce myself in a bit, but we are O1 Labs. We're a global and remote company that incubated the Mina Protocol and now working on really cool ZK technology. Check out our website, Twitter, and our careers page. I'm Regina. I'm a developer relations engineer at O1 Labs. And we have two colleagues with me joining today, Samuel and Jack. This is Jack. Do you want to say hi? We're all nice. We're all developer relations engineer and awesome people to connect with, I feel, non-biased. Today, we're building a simple zero-knowledge smart contract, or ZK app. And you'll learn about tools and libraries for writing ZK, such as our ZK app CLI and O1JS. If you're familiar with, also just curious, post in the chat. I'm curious to know how many people here watching are familiar with Mina or writing ZK apps. That would be pretty useful to know. Just like say me, or I'm familiar. But if you have been following Mina for some time or already built ZK apps before, our product used to be called Snarky.js, but now it's been renamed to O1JS. So just wanted to point that out. So the agenda for today is we're going to go over introduction to Mina, ZK apps. We're also going to talk about tools for writing ZK. Then we're going to get into the heart of the workshop, which is building our first ZK app step by step. And then after that, we'll share a little bit about what you can do next with everything you've learned, and then we'll have time for Q&A. So to follow along, I recommend you make sure you have Node.js, NPM, and an IDE installed, ready to go. I'll be using VS Code today. So if you have VS Code, that's probably preferable. But if you're comfortable with something else, go for it. I also recommend opening up the tutorial here. Actually, let me post the link, or maybe Jack, can you post the link of the slide to the chat? And then you can also open the links as we go along. But we'll be following a tutorial called Hello World, and it would be really helpful to open this up. And then finally, this might take a little bit of time, but while you're listening, download our CLI, and we'll go a little bit more into what that is later. So now we're going to introduce what Mina Protocol is and what ZK apps are. So what is Mina? Mina is a layer 1 blockchain built on zero-knowledge proofs. We use recursive zero-knowledge proofs to verify the state. And so how does Mina use recursive zero-knowledge proofs? Well, we use a zero-knowledge proof specifically called ZK snarks that supports the concept of recursion. Basically, a proof can refer to itself. And one of the benefits of Mina's proof system is the following: trusted setup, custom constraints. We have a constant proof size, recursiveness, and plonkish. If you have any questions about this, we can talk about this later in the Q&A. So one reason why Mina was created or even developed in the first place was around this time, you might know that other blockchains such as Ethereum, Bitcoin, they're growing increasingly in size, actually way more than 400 gigabytes at this point. Whereas one of the benefits, thanks to ZK of Mina, is that we can stay a constant size. So because of ZK, Mina offers many useful things. One, it keeps the blockchain very scalable. We can replace the blockchain with the easily verifiable constant size cryptographic proof. Also, the second benefit of ZK is ZK apps, zero knowledge apps, which are smart contracts that allows you to use Mina's unique zero knowledge technology. And what that enables is privacy. We can use cryptography to prove that something is true, and off-chain computation. So we can compute very complex things off-chain, incur only a flat fee to send a little zero knowledge proof to verify. So what are ZK apps? As I mentioned many times so far, they are our smart contracts powered by ZK snarks, also known as zero knowledge apps. We use an off-chain execution and mostly off-chain state model. So what does that mean? To understand that, let's take a look at how Ethereum works. With Ethereum, all smart contracts, the computations for smart contracts happen on chain. So anytime Ethereum is making a computation, you're also sending a transaction. And this can get very expensive over time, especially given the price of ethers or gas. Let's see, with Mina, all the computation can happen off-chain. And all that's happening on-chain is verifying that the computation happened correctly. In other words, you're only sending a very tiny proof and some state changes to Mina. You do need a transaction to verify a computation goes through successfully, but one thing to keep in mind is the nodes on Mina aren't actually running the computation. You're just verifying the proof. That's it. So here are the benefits of ZK apps. It's succinct, it keeps the blockchain small. There are privacy benefits, such as keeping computation or some of the user data private and off-chain. It's also very efficient because no matter how large the computation is, the cost and time will be about the same. One quick thing, I'm going to see, I think someone is on mute. I keep hearing shuffling. Oh,
I think they're muted now.
Oh, okay. Thank you. This is Samuel, by the way, our other DevRel. So how do ZK apps work? The best way to, or at least for me to understand how ZK apps work is look at it from a user experience. So here is an example here, or this is kind of a diagram that walks through a ZK app that checks if a user is older than 18. So here I am on the website, and I'm going to submit my birthday. Maybe it's a driver's license, or I'm just manually entering it in for now. Once I submit my birthday, the ZK app will check if I'm older than 18. If I'm not 18 older, nothing happens. All good. If I am 18 older, the ZK app will generate a proof and send the proof in a transaction to an address on Mina. And there, Mina will verify, is this proof valid? If it isn't, it rejects the transaction and nothing happens again. If it is valid, it accepts the transaction. And if there are any state changes that happen, it'll go through. That's it. That's really the high level overview of how a ZK app works. The architecture of a ZK app is pretty interesting too. It actually consists of two parts, a smart contract and a UI. And the UI is what enables users to be able to interact with your smart contract in the first place. Just wanted to point out both are written in JavaScript. The UI and ZK app combined can be a website. So how do you write ZK? Luckily at O1, we built a few tools that will make it really helpful and easy to do this. One of them is a ZK app CLI. The CLI is a toolkit that makes it super easy to write smart contracts. It provides project scaffolding. It uses existing technologies such as NPM, TypeScript, ESLint. It also automatically includes O1.js, which is the library we're using to write smart contracts based on zero knowledge proofs. So you might have noticed TypeScript in the last slide. So O1.js is a TypeScript library, enables you to write circuits and smart contracts in a language that most of us are familiar with. It also enables your smart contracts to be accessible from the browser. So when you download the CLI, OON.js automatically comes with it. Also, OON.js makes it super easy to build ZK circuits. You don't need to have an advanced degree in cryptography. You could, but it's not, one of the requirements. You can just focus on writing the logic of your smart contract in TypeScript. So I also wanted to point out what the developer experience might look like for writing a ZK app. And this is kind of a similar chart as the last one. So firstly, as a developer, you're going to build your ZK app, which is your smart contract and a website. Once you deploy it using the CLI, it'll generate two things. First, it'll generate a verification key, which will be sent to a Mina address on the Mina blockchain. And once you send the verification key to this address becomes a special address that will, moving forward, verify proof sent from your ZK app. It'll also generate a smart contract, a JavaScript file. And with that, you can integrate. Sorry, I would like to make a quick correction. You're not building the website in the beginning. You will build a website after you deploy the smart contract. But once you deploy smart contract, it'll create a JavaScript file that you can use to build your website. So just let you guys take a look at this for a little bit, because we'll be doing this part today up to here. I don't know if you can see my mouse. All right, so let's get started. Firstly, any pressing questions about what I just talked about? Samuel and Jack are both in the chat too. So even though I'm talking, you can ask questions. Also, it looks like everyone is familiar with Mina. Cool. That's awesome. I'll share the results. So what are we building today? Today, we are building a pretty simple app that stores a number on chain. And one of the rules about this number, or the rules or logic of our smart contract, is this number can only be replaced by a private input that's equal to the square of the number. So for example, if we start out with n is 3, the only way we can change this to a different number is if we submit the number 9, which is its square. Just a reminder, this is completely based off tutorial 1, Hello World. So if you would like to open this up, both our repo and the tutorial, it would make steps. They're outlined here. And we're going to start with installing the CLI in case you haven't done that already. So just a reminder, a CLI is what makes it easy to write ZK smart contracts. So to download the CLI, please not using that for the next few steps. And make sure everything's installed and up to date, Node, NPM, and Git, as well as make sure you have ready. Next, we're going to download the ZK CLI by running this command. And this will make the ZK command available in your system. So once it's downloaded, you can check to see if you have the correct version of the CLI. Right now it's 14.0. So even if you've already downloaded the CLI before, highly recommend you check the version of your CLI. And this is what we get. If you type in ZK or ZK help, you can see all the commands that are available. There's ZK project, ZK file. You can create an example project and ZK system to see how everything is looking on your end. So we're done with step 1. Pretty easy. Now we're going to create a new project. And to create a new project, we'll be using the ZK project command. Basically, enter in ZK project 01 hello world. I will demonstrate what this looks like here as project 01 hello world. So it will get some questions after you enter this in. For now, we will none. Select project. I'll talk about that question a little bit later. It'll take a little bit of time. So while it's setting up, let's see what the next step is. Oh, this is what you should see. Okay, my computer is a little bit slow. I will move on for now, but this is real. It's happening in real time. So once you have your project downloaded, enter your, we're gonna take a look at your project and what has been created. So just enter in the hello world file or project, and then enter in ls to see what's going on. And this is what you should see. For this tutorial, let's see, we're going to be running commands from this particular file. So keep your tutorial open, make sure you're in the hello world directory. There's a couple folders we're going to be primarily touching. One is mainly just the source file, the source folder, and we'll talk about that in a bit. But the one thing to keep in mind is everything we're building is in the source file. And once we deploy it, our TypeScript file will be compiled into a JavaScript file that will be found in the build directory. Let's see if nothing is happening right now. Okay, I think we're going to be primarily working off now, but let me know if you're having any issues at this part or at any point. And yeah. Okay, so let's go inside our source directory, just take a look at what it is. This is actually may not be totally accurate. There was a few files that came built in a project. Our file name would be so. Once is loading. Let's try it again.
Oop. Regina, I think your internet might be cutting in and out a little bit.
There is
I don't know if that's happening for everybody else too.
Yeah, it's starting out.
It is? Okay, maybe while Regina is reconnecting. Oh, there we go. She's back.
Hello.
Oh,
Yeah.
Hi. Sorry. Yes, I definitely had internet issues. I'm going to go back to where I started. Let's see. And is that hopefully everyone's following along at this point? Let's see. Where are we? We were here. I'll start back here. Okay, project file structure. So were you, Jack and Samuel, was everyone able to hear this part or? Okay, cool, thank you. Yes, audio is better now. Man, how long has that been going on? Okay, this explains a lot. Okay, all right. So at this point, we are, hopefully you have your project open, your Hello World project. We're going to enter in the source directory. In this directory, in this particular folder, you might see a few default files called add. We're going to ignore that for now and just create our own files called square. So in your terminal, enter in ZK file. I'm going to exit this for a little bit. Let's start over. Sorry. One second. And just out of curiosity, how many people, oh, share screen. Yes. Oh my gosh. Can everyone see this? Okay. All right. So I'm in the Hello World directory now. Okay, cool. Everything's looking normal. Also just curious, can you like say something in the chat if you are actually following along with the workshop, or if you're just listening, that's totally fine too. But it'll be good to know as well how many people are like working step by step, and I can adjust the pace based on that. Okay, so now we're back in the directory of Hello World. Now we're going to enter in our source directory. Whoops. And we can see that there are some files that are already included in part of this. We're going to ignore pretty much all of this for now, actually, and make our own brand new smart contract file. So just type in ZK file square. Oops. And when you do that, it will create a bunch of new files, a square TypeScript file. That's actually where we will be writing our smart contract, and a test file. We're not going to touch that today. We're going to focus on this one. I think we need to create something else too, a main file. Yes. Yeah. Also create a main TypeScript file. Okay, so this is what, whoops, I'll clear it, make it more clear. This is what should be in your source folder at the moment. Let's continue. Also, how's it going? I created this slide here just to check in. Is everyone following along? Pete says listening and absorbing. Great. Cool. Let's continue. All right. So we're already at step 3. We already installed the CLI. We created a new project and the necessary files. Now is the heart of writing a ZK app, the smart contract. So open up your code editor. I'll be using VS Code. Let's see. Yeah, I'll be using, yes. Okay, so let's open up VS Code. And open up your Square TypeScript file. At this point, this is why I recommended opening up that tutorial and also the repo, because we're actually going to be going to the repo and copying over the example over to our own code editor. So let's do that. I have the Hello World repo opened. I'm going to go to source, open up Square. And on my own computer, I will also go to the Square TypeScript file. Okay, this will just make the workshop go a little bit quicker, and feel free to look at this in your own time, or we could look at it at the end during Q&A. So if you have the repo open, let's take a look at what we're looking at. Here's kind of a high-level overview. In the code structure, basically we have 2 main parts. We have the import statement, which is pulling everything we need from the O1.js library. And we also have our smart contract class, which is where all the logic is written. So just a quick disclaimer here. All of the O1.js library, you can find the references and everything you need to know about it actually on the docs, on Mina docs. You can search for different functions. You can find out how everything works. I definitely recommend checking out Mina docs. All right, so back to our smart contract. In the beginning, we have our import statement, and here we are just pulling things we need for our smart contract today. The ones that we wanted to point out here are field. This is our native number type in O1.js. We have a smart contract class, and that's what makes it possible to write ZK apps in the first place. We have method and state, which are a couple of decorators that are used to mark methods that users can call. And also the state decorator refers to state stored on chain. We also have another class also called state, and that is the class used to create state stored on chain in the first place. And all this you can find back in the Mina docs in the O1.js reference. Smart contract class. As I mentioned earlier, the smart contract class is what makes it possible to write smart contracts in the first place. For us, we're going to extend it and create a smart contract called Square. And here, Square is going to have one on-chain state named num with the type field. So just in case you're wondering, ZK apps can have up to 8 fields worth of on-chain state. And this is equivalent to 32 bytes of arbitrary data. So in the smart contract, we're going to start out with a init method, and this will set up the initial state of the smart contract once we deploy it. So you can see we have init, and then we're setting the num, the on-chain state called num to 3, which has the field type 3. And this might be super new to everyone, but we'll get a little bit more familiar over time. But this is kind of example or taste of what O1JS looks like. After that, we will write the logic for what's going on with our smart contract. As I mentioned earlier, the method decorator is basically what the methods that users will be interacting with. Here we're calling it update. And this update method takes one input called square, or it'll be a field element. And you'll see here, we're assigning, we have a few logic here where we're assigning we're trying to figure out what the current state is with the current state. So it should be 3. And then we also have a couple methods, which I'll talk about later, but just take this in for now. So how do state updates work in the first place? O1JS has a bunch of methods that we would call into a group called assertions. So assertions are special O1JS methods that generate proofs when the conditions are met. And when all the conditions of these assertions are met, a proof is generated. And this proof will be sent to Mina in a transaction where if it is valid, the on-chain state will be updated. If it is not valid, it'll throw an error and prevent you from either generating a proof or sending a transaction to Mina. So a couple of slides back, that's what was going on here in the smart contract class. We are using a few assertion methods over here to make sure that, everything is working properly and make sure that only the square of the number can cause the on-chain state to change. So after you write the smart contract, you'll typically want to build a UI so that users can interact with their smart contract. We're not building a UI today, but we'll be writing a script that will interact with our smart contract and kind of represent the same thing. And if you would like to learn how to build a UI, there's a link at the bottom in the slide, and you can check it out and follow the tutorials. The UI can also be written, just want to let you know, it can be written in any framework or just plain HTML JavaScript. And that's kind of one of the benefits of the ZK Dapp CLI. The CLI has a cool feature that can scaffold any UI project with any of these frameworks. So just want to check everything good. Okay. So at this point, let's say we build our smart contract, we have a UI, or in our case, a script. We need to prepare our smart contract so that our script or UI can access it. So we're going to open the index file and copy this over. And the index file is basically the entry point for our project. And again, everything is available on this repo. Index is right here, and you can just simply copy this over. It's actually already here. So I would just change this square. Let me just do this real quick so that everyone can see what the experience is like. Just copy this, paste. Yeah. So yeah, at this point, our index file or square file should be something like this. So quick midpoint recap. We've written the smart contract code in Square, and we updated our index file so that Square can be accessed from a UI. Now we're ready for the next step, which is to test on a local blockchain. Everything good? Cool. So we're interacting with the local blockchain. So there are a couple ways we can test smart contracts in general with ZK Dapp. We can either interact with the local blockchain, or we can deploy it to a test net called Berkeley, which we'll do at the end. To set up a local blockchain, we're going to write a script that allows us to run the smart contract locally and that script will be in the main TypeScript file. It's a much bigger code snippet, but I will break it down. It's also quite similar to how the smart contract was set up. We'll have an import statement as usual, and the second part will be setting up the local blockchain, and then the second half will be us deploying our smart contract, interacting with it. We won't go into this too in depth, but I'll talk through it so that you understand what is happening. So again, we have our import statement at the top, and we're importing field, Mina, a couple of different things from our smart contract, private key account updates, and all of this you can look up and find out more in the 01JS reference. So from lines 10 through 17, we are setting up our local blockchain. What's also happening here is we can actually generate and verify proofs when we're interacting with the local blockchain, but for this example, we're setting it to false, or we're disabling it just to make things go a little bit faster. So let's see. Actually, let me just point out. Here's main. Let me do this first. So I recommend copying this over, going to your main file. And that's it. So the next few lines here, we're just creating a console log message letting us know ready to go. And oh yeah, we already mentioned this. Sorry, I'm losing track of where I am, but cool. Next up, private key, and we're basically deploying we're setting up our private key here. It's going to be something random. And over here, we're also deploying our ZK app to a Mina address. So deployer key is our address and where we want to deploy it to. And once our smart contract is deployed, this is the address we'll be using to send transactions to from our smart contract or from our ZK app. You don't have to read this tuned up right now, but just kind of get an idea of what's happening. So now we're at the part of where we're writing test cases, basically. So due to off-chain execution, there's always potential for race conditions to happen. So one of the first things we need to do is make sure that no one has changed our original value, which is why we have a line here checking to see what is our on-chain state. So if you remember back, many slides back, we set the num to 3. So we should expect that in our console, we should see state after init should be 3. We're going to write a couple more test cases here in the following lines. We're going to test it with 2 transactions, test if 9 works, it should, and we'll check if 75 works, and it should fail because 75 isn't a square of 9 or 3. So that's what these 2 transactions, or that's what's happening here. All right, so let's run our script. Let's try it out. Yeah, just want to recap. I went through kind of all the parts of this. Oops. So to run your script, just enter in npm run build, node build, just run this line, unless you are already in the source file, but just edit this to where you are right now. So I will give that a try myself. Okay. So it works. Okay, I have some error messages. Ignore, pretend this doesn't happen for now. But if everything worked normally, it should look something like this. We should see the message saying O1JS loaded. We should see the state, the initial state, and we should see the 2 test cases work, 9 and 75. And then in this slide, the smart contract is tested and ready for a live network. And if any of you are getting these exact error messages, I was actually stuck on this yesterday. Let us know. I'm curious to know if it's working smoothly for everyone. But so we're going to deploy now to the Berkeley testnet. So what is Berkeley? Berkeley is Mina's live public testnet. Right now, you can deploy ZK apps to Berkeley, and we're at the final stage of making this same capability available on mainnet. The ZK app CLI has a feature for easily deploying your ZK app to Berkeley. So deploying is pretty easy. If the last part works smoothly, this is how I would have done it. Enter in the command ZK config. And this is basically the feature that comes with the CLI that makes it possible to deploy to Berkeley. It'll create a couple files, a config file and a keys folder. So this is what it should look like. It'll ask a few prompts, such as what network you would like to, or like what network you're trying to access. I pasted the info here. I recommend just entering Berkeley, copying this URL over, and oh, this is kind of the interesting part, the fees you want to pay. So most likely, if this is your first time building this from scratch, you will also need to request test funds. So all you need to do is go to our faucet here, enter in your address, and click request. This process will take probably a few minutes, so don't worry if you don't notice anything happening or you're not able to deploy right away. So after a few minutes, you can deploy pretty simply using your CLI, ZK deploy Berkeley. And at this point, your smart contract is deployed to a live network. Yay! I'm sorry, I can't show this real time. That'll be really satisfying, but let me know if anyone here has gotten to this point. Yeah, so we covered a lot today. We covered a little bit about Mina, how it works. We covered the benefits of ZK apps, the architecture, the user experience, as well as developer experience. We also talked about the ZK app CLI, as well as O1JS. And during our workshop, we looked into what it's like to create a ZK app project, what it's like to write it, test it, and deploy it to our testnet. So what are the next steps? We have a really active community on Discord that can help out with any questions or have discussion with you about what types of ideas you like to build with your first ZK app. So check it out, join it. We also have over 11 tutorials on our Mina docs. There's also weekly developer office hours that Samuel, Jack, and I will be on, and other members of O1 Labs. There's also a couple time-sensitive opportunities happening. We have a Mina Navigator program that you can apply to. I think the applications are due tomorrow or this week. So definitely check this out today if you are interested in that. If you're also interested in joining ZK Ignite, that's also a really cool program that you can submit a project idea and build together with a bunch of other developers. That's also really cool, and you can find out more info about that there. Yeah, so I just also want to point out some things that O1 Labs is working on. Well, as I mentioned, we have ZK apps coming soon on MeNet. Super exciting. Just this is a great time to be learning and building a ZK app. We also have a couple of new features coming out. We have ECDSA signature verification coming soon and chunking. So check out the RFC here if you're interested in these two things. And yeah, we're also going to be heading to Istanbul in a week. And so if you will be there, or for Phoenix Guild ZK month, I think some of us will drop by for sure. So yeah, thank you so much for watching this workshop. Yeah, really appreciate it. And now we're ready for questions. And Jack and Samuel, feel free to jump in or unmute. There's definitely questions sometimes that I feel like I can't answer, but you two may. Cool.
I have one that's in backlog that I'm typing out like a text wall for, so I figure I'll just sort of say.
Okay.
This is from Ovia Seshadari, and it's, if the Mina blockchain is a fixed size, where does the verification logic live, and how do the decentralized nodes know what logic to verify? So this is a really good question. The 22 kilobyte figure, or the idea of Mina being a fixed size, this is true, but this doesn't include, I guess what I would say is, so if we think about how Ethereum works, we have basically people send transactions to Ethereum. Ethereum takes existing data on Ethereum. It does something with this data according to what the transaction asks it to, and then it stores the new data. And so the result is that in order to verify like the most recent, data on Ethereum, the only way that we can do this is to go back through every single block and basically compute what is the difference from the genesis to now. And so the result is that as time goes on and people send more and more transactions, we need a larger and larger amount of data to verify that the current data is true. So Mina doesn't have a way to get around this idea that people are going to do stuff over time, and this is going to basically create like historical data. But what it does have the ability to do is get around the need to maintain this historical data in order to be able to verify the current data. And the way that it basically does this is, right, people send transactions, we do sort of the same thing that you do on Ethereum, but because all of these transactions are coming in because they're verified by zero knowledge proofs, what Mina can actually do is, after it has some of these transactions in its history, it can verify these transactions and prove that it verified these transactions inside of another zero knowledge proof. And then it can just keep that zero knowledge proof as basically I guess like a part of the data that it would send to like anybody who's interacting with the network. And then it can forget this historical data. And I guess to touch a little bit more on this, there's also sometimes when you need this historical data. And so there is a type of Mina node called an archive node that does store all of this historical data and lets you query it. For example, if you were going to run a block explorer, or you had some, I don't know, application that needed a bunch of historical data about Mina for some reason, but you don't need this in order to verify the current state. And then that actually ends up being more valuable than it sounds. I'll actually drop in to the chat. This is a pretty cool example of what you can do with that. This is a project called OpenMina. I'll just dump it in the main chat. This is a project called OpenMina. And this is actually a full Mina node that runs in your browser. So sort of the same like user interface and idea as something like MetaMask, but whereas MetaMask is connecting to a node that's running in a data center somewhere, usually, the OpenMina node actually runs right inside of your browser. So yeah, that's cool. Sorry for the kind of ramble, but yeah, I don't know if there's other questions. I'll read through them, or somebody else can jump in, or just feel free to unmute.
Amazing. I think that was like a great session. If anyone has a question, feel free to unmute or drop in the chat, whichever way you prefer. And I would like to thank all our speakers today for giving out their valuable time. Everyone, do share your learnings over Twitter, and you can tag our speakers, you can tag Regina, you can tag Mina Protocol, and give us a shout out. We'll also be in Istanbul for the ZK Unleashed event, and there's a lot in store that we are planning. There are a lot of games and fun activities and a lot of cool swag as well. So register if you haven't, and we'll see you there in Istanbul.
Cool. I think there's one more question from Pete.
Yeah.
He says, do you think it could be possible to use a ZK proof to verify some code was free from vulnerabilities, aka if the example has been audited?
Yeah, absolutely. This is a cool use case, and we had somebody in the community who was working on this maybe about a year ago. There is some, I guess, like subtlety in this. I think the kind of like MVP for this is just basically right, like I think in theory you can, there's sort of no limit to how far you can take this. You could prove that you run some like static analysis on something, but this is like a heavy lift to build. And so what this person was working on is basically just like a test runner in the on the blockchain, and then also the ability to add some bounty if you can make a test fail effectively, so that and I think there's also like a handshake where you there's also some way that the person who found the vulnerability committed to the vulnerability, but I don't remember exactly how that worked. But yeah, you can imagine if you just had a smart contract and then you had sort of like bounties for making it fail on chain, and you had the ability to prove that you've made the smart contract behave unexpectedly in some way, without revealing what your input is until the people who have set the bounty pay you, then that alone is like a cool, yeah, I think that would like practically improve security.
Yeah, that's cool. It also, I can think of ZK being used for like, yeah, the bounty program, proving that you did find a bug and then receiving, prove that you did. You don't have to share where the bug is or how it happened. But there's a lot of potential there for security actually.
Okay, yeah, I think there's one more question that has to do with like vulnerabilities or things to consider when building a DeFi hub. And I think just like just like when you're building smart contracts, you just have to like, prioritize audits. Mina ZK Snacks is super secure, but you need to like, still enforce strict access, still like, make sure there's like, proper authentication. And yeah, educates, people that are going to be using your dApps on like, security measures and stuff. So yeah, pretty much standard for most most dApps. Yeah, Mina is definitely secure, but you still have to like, take normal security measures like for different.
Yeah, this is true. There's sort of no substitute for, I guess, just like, doing the things that anybody has to do on any blockchain. There's one more question that I think that this is sort of answered, but I'll just explain kind of like the whole big picture for how the Mina accounts work, because I think it's interesting, and I also think that it's like it's a lot easier to learn everything else if you know how the accounts work. So on Mina, basically, like an externally owned account and a smart contract account, they're a lot closer to the same thing than they are on a blockchain like Ethereum. On Ethereum, these are basically totally different things. On Mina, like if I want to make an account, I generate a private key, and then I generate a public key from it, and then I control this account. And the account doesn't actually exist in the ledger until I send a transaction to it, and I pay a 1 Mina account creation fee to basically buy that space in the ledger, in the hard drives of the nodes, I guess, in the short term. So after I've done this, then I have this account, and the account has a bunch of permissions, and I can change these permissions. So the permissions can be set to either proof or signature or none or both. And so, the permission might be something like change the permissions, or it might be something like, send a balance into or out of this contract. And so the permissions are set such that you can change the permissions with a signature at first. So I generate my private key. I have, the ability to create these signatures. But then what I can actually do is I can turn this account into a ZK app account if I want to, by adding a verification key into the basically like the data for this account. And I would do this by signing a transaction that says, hey, I'd like to add this verification key to this account. And after I've done that, then I have an account that I can also go, send a signature and turn on proofs for certain things. Like I could turn on, I could set send or receive Mina to proof or signature. And then what I have is I have an account where I can use it like a normal account that I own, because it is still a normal account that I own. And I can, send and receive Mina using a signature. But what also a person can do, a person who's not me, a person who doesn't have the private key, they would be able to use the smart contract that's associated with this verification key that I added to the account. And if they generate a valid proof, then they can also send and receive Mina. And so in this way, you can have an account that's sort of externally owned and a smart contract at the same time. And then you can, if you want to, get rid of this idea that a person can do whatever they want to with the account because they have the private key, you can actually also just go set all of the permissions on the account to proof only. and then you have an account that's very similar. It works basically identically to a Ethereum contract account where this is just code. If you want to upgrade the code, you have to redeploy the contract. All that stuff. So I guess another specific question that was asked in that is, can you upgrade smart contracts? Like, can you change the verification key for an account? The answer is that the account isn't defined by the code like it is on Ethereum. On Ethereum, the account is like a hash of the smart contract that you've written, basically. On Mina, the account is just a thing that is based on what private key and public key you generated. And so if you wanted to do something like change the smart contract deployed to that account, as long as the permissions were set the right way, you could. But if you wanted to deploy a smart contract that couldn't be changed, similar to an Ethereum account, then you would, deploy this smart contract, set the permissions to proof only, and then you would have to redeploy to a new account in order to change the code. So that was kind of a rambly explanation, but I hope that sort of like gives you a good mental model for how the Mina accounts work.
Yeah, I also just shared a link just in case you want to like learn more on account updates. Just emphasize on what Jack has said so far.
Yeah, that was a great explanation. Thanks, Samuel, too, for the link. Are there any other questions regarding how ZK Dapp accounts work or building DeFi apps? Or that's it. Yeah, you can also reach us on Twitter or the Discord channel, or meet us in Istanbul. We'll be around.
Hey, thanks a lot, Jack, Samuel, and Regina. This session was definitely very useful for many people here. I'm sure of it. Guys, please do share your learnings on X and make sure you tag our speakers and O1 Labs. And any questions you have, please feel free to ask them as well, or you can pass it on to us and we will forward it to them. Yeah. And thanks a lot, guys. I look forward to meeting you all in Istanbul.
Yeah, looking forward to meeting you all too. Bye, everyone. Have a good day.
Thanks, everyone. Bye-bye.
Bye.